Good morning. I know in class you've been asking for some more examples of solving exponential and logarithmic equations. So over the next couple days I will post some more videos. Feel free to work along with these problems. Now notice I've rewritten these. If I was to use this property from Algebra 1 that says if I have something to a power and raise it to a power, I keep the base and the new power is the product, I can rewrite 4x as 2x times 2. And I go do this. Okay. Now let's go back to Algebra 1. If I would have given you u squared minus 7u plus 35 is 0, you would look at that and you'd say, oh, can I factor it? Well, let's see. Are there factors of 35 that add to negative 7? The answer is no, there's not. Well, there is an option, and that's called the discriminant. Let's see what happens. The discriminant from Algebra 1 says b squared minus 4ac. Okay, we're going to look at that. That's what's underneath your radical. If it's 0 or positive, you have a real answer, right? However, when we're over in this land, exponential land, we got to test because we can't take a log of a negative number because logarithms, well, we'll get there in a second. So let's see. 7 squared I think is still 49 times 1 times 35. We can see that this is far larger in magnitude than this. This is negative, so there are no solutions. Okay. Let's take a look at this second example. Same idea. I rewrite this as 2x and I square it. Looks like it's the same thing. My identification, if u is 2 to the 2x, I can see this as u squared plus 9u plus 15. Are there factors of 15 whose sum is 9? I don't think so. I mean, 3 times 5 is 15 and sum is 8. B squared minus 4ac. Okay, b squared, 81. Minus 4 times 1 is 4. 4 times 15 I think is still 60. That's 21. I believe 21 is still positive. That means the discriminant gives me two answers. Okay? So in Algebra 1 you would have said u is equal to the opposite of b plus or minus the discriminant, well, the square root of the discriminant, excuse me, we've already done it, so let's go ahead and use it, all over 2 times a, which is 2. However, remember this, u really was 2 to the 2x. So let's think about this. So I get 2 to the 2x equals negative 9 minus the square root of 21 over 2. Or I get 2 to the 2x, running out of room, equals negative 9 plus the square root of 21 all over 2. Okay. This answer here is clearly negative. And this is exponential growth because 2 to the 2x is 4 to the x. 4 to the x is never negative, so no solution. Okay. Now over here the question becomes, hey, what's the square root of 21? Okay, the square root of 21 sits between 16 and 25. So 16 and 25 are 4 and 5 when I take the radicals. They're square roots. So this is between 4 and 5. Notice this number is still negative. No solution. Now, let me pull up my computer and let's take a look at those two answers for a second. Hold on. So as you can see, I've already graphed it and I've put a new window here. When we set this equal to 0, what you're really asking yourself is, does this function ever intersect the x-axis? If it does, the y value will be 0. Notice that because of how this was written, it didn't work. So you have to be careful when dealing with exponentials. And I'll do more videos this weekend. Have a great day and have a great homecoming.